The first step to performing test and balance on any terminal unit is to verify that it has power and communication. Power by seeing if the controller's power light, seen here, is on, and communication by if the Ethernet ports are plugged in and the associated COM lights, in this case the green and yellow lights on top of the controller, are on. If you'll be using the thermostat to set correction factors and record initial values of the unit, you will also need to confirm communication and proper operation of the thermostat during this time. Otherwise, you will need to be able to interface with the controller through its IP address and access the controller software to make your adjustments. Whether using the thermostat or control software to navigate the various control states of the SACV, when using the thermostat, this will be performed by holding the central button for a few seconds until you are prompted for a password. For this unit, the password is 9995, after which you will enter a configuration menu. You will navigate to the balancer mode, press up to enter, and the mode to look for is mode 4. Once the SACV has stabilized at its max cooling airflow, we need to know what our actual flow is doing rather than just what the unit thinks its airflow is. And for that, we need a traverse. Per AABC standards, any flow corrections are to be set using an appropriate pitot tube traverse as reference. This will apply both to correcting the SAV airflow as well as the correction factor of the flow hood. For more information on conducting duct traverses, check out our YouTube channel at youtube.com/engineered air balance. In this case, our traversed airflow was 450 CFM, which we will use for all future corrections. Once we have our traverse, it's time to set up our correction factor. And for this one, we'll be using the control software. With a traversed airflow of 450 CFM, and our unit showing 506 CFM, we'll calculate our K factor, and it will come out to 0.89. We'll then right-click our control point, in this case room offset K factor, go to BACnet object, set value, type in our value, 0.89, and hit OK. Once we've done this, we'll see that the flow versus the actual flow SACV points to the right on our control software will now have different values. You'll want to give the terminal unit a few minutes to come back and fully control at the corrected airflow, and potentially check your traverse again to confirm that everything is agreeing. Once our unit airflow has been corrected and we're operating at the correct set point, in this case 500 CFM, we need to take a reading with our flow hood because the flow hood also needs to be corrected. They are a proportioning tool, and while most hoods come calibrated from their manufacturers, there is no accounting for things like system effect, installation considerations, and other factors that are specific to job sites, specific to the different kinds of air diffusers, and specific to how much care has been taken of that instrument during its lifetime. It's these reasons why a correction factor needs to be applied. Now, in this case, our traverse and our terminal unit are in agreement that we are at 500 CFM, but our flow hood says that we are at 550. So, to correct for this, we will go into our menu. We will go down to our CF selection menu, navigate fully into that, and now this is specific to TSI Alnor. Different manufacturers have different input methods. For this hood, we can choose which correction factor we want, and then we can assign the correction factor that we need to that number. With our airflows of 500 versus 550, our correction factor is a 0.91. And once those changes are saved, we'll navigate back to the base menu, and we'll see that our value of the flow hood now shows the CF to signal that it is a corrected value, and our flow is in agreement with our hardware. We're at 500 CFM across all of our traverse, our unit, and our flow hood. Once your flows have been corrected at the max airflow volume, the next step for the SACV is to override it into its minimum airflow. Using the T-stat, we'll navigate the menus to get back to our balance mode override and select mode 2, which is minimum flow. After entering that command, we'll see that our flow begins decreasing to our minimum airflow set point. In this case, our minimum airflow set point is 50 CFM. Once our airflow is sufficiently close to our minimum airflow set point, we will re-navigate through the thermostat menus to get to our minimum room K-factor and put in the associated K-factor. In this case, both the maximum and minimum K-factors calculated were 0.89. So we'll put in that same 0.89, let our flow correct, give the unit another minute or two to get back to its minimum airflow set point. When you're dealing with airflows this low, that may not be necessary, but you want to make sure that before you take final readouts that you are operating at the set point you should be operating at. The correction factor of our hood should not, and thankfully does not, need to change in this setting. Once we corrected our terminal airflow, it was showing around 47 CFM. Our flow hood is showing 45 to 47 CFM as well. And that's all she wrote. Now, what is the importance of these correction factors? And what are the considerations to make when obtaining and applying them? The biggest one is making sure that your flow hood is seated correctly around whatever diffuser you're reading, right? You don't want any gaps. You would prefer not to have any tearing in the skirt material of your flow hood. You want to make sure everything is seated and sealed fully so that any and all airflow coming out of that diffuser is the same any and all airflow coming through your flow hood and being fully read.